Let's go through the advantages of this. The framework itself is elegant because it's simple. And when you look at a piece of work done on the ToBI system, I think your first reaction might be, that looks pretty clever, that's pretty neat. The basic ideas, as I've explained them in about 2 minutes and 15 seconds, is very easy to understand. There's a central role, not for pitch that we perceive with our ears, but for, the abbreviation is F0, fundamental frequency. This is the frequency of the vibration of your vocal folds, and it's something which is objectively measurable. You can use a computer and you can work out, if two people disagree, if two experts, one of them says that's high followed by low, and the other person says no, it's high followed by high, but with a slight down step, you can say, okay, one of us is right, one of us is wrong, the computer will decide. And then you get the computer to analyze the fundamental frequency, which equates to pitch, and it's settled. So the central role of fundamental frequency gives it a degree of objectivity. Well, I've already mentioned the testing of inter-transcriber agreement. The people working on ToBI tried to extend this to other languages, so that, for example, there have been ToBI treatments of German, of Hungarian, of Swedish, a number of other languages. Now the disadvantages, because I'm afraid it all went wrong as far as I'm concerned. It was something which had a great beginning. It was a lovely golden dawn. And then doubts began to creep in. A number of people who didn't get enthusiastic about this said, well, hang on, you're saying that fall-rise, for example, is a high and a low and a high. Well, is this really true? It might be convenient to write it like that, but, and I actually believe this myself, there is something special about a contour like fall-rise or rise-fall. It is the contour itself, it's the global shape of it, not the fact that it starts low and then goes to a high point and then goes to a low point. It is a contour, and contours were not part of the basic equipment of this system. A contour was something at a higher level that you made up out of these building blocks, the low tone and the high tone. And more I came to feel that this, the importance of contours was being neglected in ToBI. Inevitably, given that the people working on this were academics, the simplicity of the original idea was very quickly spoiled by adding on more and more and more details, until the original idea, which was so easy to understand, became covered in details that made it impossible to understand unless you read all of the papers and attended all of the meetings over 3 or 4 years. It became intensely complex. People started saying, ToBI's fine, but for my language, we need a special version of ToBI. And this happened with German, for example. Half the phoneticians in Germany said, we like this, we'll go with it. And another half, led by a well-known professor, said, German is special. We will have our German ToBI. And they produced a variety that was different. And the French said, oh, well, French is different too, so we must do our own. And pretty soon you get this dilution where there isn't a single ToBI system. It becomes a whole lot of little local varieties. I said how good I thought it was that we, in ToBI, used the fundamental frequency as a crucial piece of evidence. But there's another side to that. Fundamental frequency is not intonation. Fundamental frequency is a physical counterpart to intonation, but intonation really is in your head and in your ears. It is not what a computer measures. And so it's possible, for example, and I've done this many times, it's possible to look at a line or at a contour on a computer screen and say, oh, well, that begins with a fall before it becomes a rise. But what you have to say is that fall big enough for the human brain to detect? And often it is not. If you go have a transition from a voiced plosive or a voiced obstruent into a vowel, or a voiceless obstruent into a vowel, there's a little time when the pitch will be either rising or falling, when the fundamental frequency will be either rising or falling. On a computer screen, it looks big and clear, but the human ear and the human brain don't detect it. It is therefore not possible to claim that that has any linguistic importance at all. But you can still write a paper on it and send it to a journal and prove that there's a rise in English that nobody knew about. Some people believed everything that they saw in terms of computer analysis of fundamental frequency. And finally, and a very big mistake, I think, was that the phonologists and the speech scientists who developed this system never found the time to encourage people to produce pedagogical material. There were some very good training manuals produced to teach you how to use the ToBI transcription, but never in any sense was there an encouragement to say, how would a learner of English make use of a transcription like this? That was, they more or less said, let the guys in the education department figure that one out, we'll concentrate on our theory. And I think it missed a big opportunity there. And although people are still working with ToBI or something like ToBI, and there have been some interesting cross-language comparisons. There was a book by Daniel Hurst and Albert de Cristo published 5, 6, 7 years ago, I think, which attempted to, this is a good example of what happens with academics in groups. Hurst and de Cristo said, the ToBI framework, or something like it, has become so popular, we could do lots of languages, all treated the same way, and put them in one book. Great idea. They got more than 20 phoneticians in different countries, and they did Arabic and Bulgarian. But each person wrote in and said, actually, I'm going to use my own system because I'm not very happy with what you want me to use. And if you read that book, the description of it is fabulous. It's just what we want, to see 20 different languages, all described in the same way. And then you start reading them, and some of them is clearly the part of the PhD thesis of the guy who wrote it, and some of it is written for the, I don't know, the approval of the local Ministry of Education. It just does not look like a consistent collection. So the ToBI system, I think, is not going anywhere. As far as I can see. Again, this may be a prejudice of mine that's not true, but I'm afraid that's the way I feel about it. The other final thing is, ToBI only works if you're transcribing with a computer. And I don't think it ever occurred to the people doing this that there are still some people in the world who don't have a computer. You can, if you have a big piece of paper and a lot of skill, you can do something that looks like a ToBI transcription, but a full ToBI transcription not only is highly complex, but it must be linked explicitly to the acoustic signal that's stored in the computer. If you can't link it in time to the exact physical recording, then it's not a true ToBI transcription. So it has to be done on a computer, and that's a big drawback.